Hello dear students, welcome back to our physics class. This is Mr. Idris, physics teacher. On today's lesson, we're going to explain a new section in chapter 1, section 3, causes of a circular motion. As you have learned in a previous lesson, the centripetal acceleration is an acceleration of the object that's directed toward the center and produces by changing the direction of the velocity, such as in uniform and non-uniform circular motion. In both types of the uniform and non-uniform circular motion, we have a centripetal acceleration. Okay, but on today's lesson, we're going to focus on a centripetal force. Okay, before we get started, the centripetal force, just for reminding you, consider a ball tied to a string that is reeled in a horizontal circular path, as you can see in this figure. When the ball is moving in a circular path, because the direction of the velocity changes continuously, the object experiences a centripetal acceleration. But at the same time, the inertia of the ball is tendency by exerting a force on the ball that makes the ball follow in a the inertia of the ball tends to what? Maintain the ball's motion in a straight path. Okay, this is inertia that causes the object to moving in a straight line. But because of the force of this string, the force of the string doesn't let the object to move or fly up in a linear path. Okay, so this string is provided the centripetal force. Okay, so the centripetal force is the resultant effective force. Why we say resultant effective force? Because sometimes we have more than one forces that keeps or maintain the object in a circular path. Okay, for example, when the object is moving in a vertical path, okay, for example, when the ball is tied, okay, and moving in a circular path, okay, vertically, not horizontally, by getting these 4 points, okay, at the top, there is two forces that maintain the object in a circular path or provided the centripetal force. At first, the centripetal force is directed toward the center and provided by what? By tension force and gravitational force. Okay, so at the top, we can say Fc is equal to what? Fg plus Ft. How many forces produces the centripetal force or provides the centripetal force? Two forces. But because the two forces are in the same direction or in opposite direction, okay? So the forces that keep us or provided the centripetal force, it should be the same direction of the centripetal force, such as this point, or opposite the centripetal force, not perpendicular. But if you look at this point, where is the centripetal force? Toward the center. What about the tension force? Also toward the center, okay? But gravitational force, in that case, the gravitational force is perpendicular to the centripetal force. That is why the gravitational force is not provided the centripetal force when the ball reaches the horizontal. Okay, so in that case, Fc is equal to only Ft. Okay, so that is why we say the resultant effective force, because sometimes more than one force has provided the centripetal force. The resultant effective force on a body that moves it in a circular path and it is directed toward the center of the circular path. Okay? How can you find the centripetal force? According to Newton's second law, F is equal to what? Ma. This is Newton's second law. But when we say Fc is equal to Mac, okay? And AC, as you know, centripetal acceleration is equal to what? Vt squared over R. Okay? So this is equation number 1. Substitute AC in equation number 1. It becomes what? Fc is equal to M, and instead of A, sorry, this is AC, okay? Instead of AC, write down what? Vt squared over r. This is equation number 2. In the case when mass and centripetal acceleration are given, you can find the centripetal force by using this equation. But in the case when tangential speed or the radius of the circular path or the distance from the axis of rotation is given, you have to use this equation. And also in section 2, when we studied the relation between the linear and angular speed, as you know, Vt is equal to what? Is equal to omega r. What about Vt squared? Is equal to omega squared r squared. Substitute in equation number 2, Fc is equal to m, okay? And instead of Vt squared, write down omega squared r squared over r. R with r cancel. What is remain? Fc is equal to m r omega squared. So this equation can be used to find what? The centripetal force for an object on a rotating body. For example, when someone's standing on a merry-go and the merry-go spinning in a circular path, okay, about the fixed axis, to find the centripetal force for this guy who's standing on a merry-go, you have to use this equation. Or another way, if you have a bad time here, so you can choose this equation when the angular speed is given, okay? Look, as you can see in this figure, the direction of the centripetal force is always directed toward the center, which is parallel to the centripetal acceleration, okay? As you can see in this picture, what is the angle between FC and AC? FC and AC is parallel to each other. The angle between them is 0 always, okay, at each point. So what about tangential acceleration and tangential speed? Also they are parallel to each other in the case of speeding up, and they are opposite in the case of slowing down. So it means that the angle between AT and VT is 0 degree in the case of what? Speeding up. But in the case of slowing down, Vt and At are opposite to each other. The angle between them is what? 180. When does angle between Vt and At is 180? When the ball is slowing down. Okay? Look. What about the angle between FC Vt? 90 degree. FC At 90 degree. AC Vt also 90 degree. AC At perpendicular 90 degree. Okay, so this equation Fc is equal to mv squared over r. This is the centripetal force for the circular motion when the velocity is given. But when we say Fc is equal to m omega squared r, for example, this is merry-go. Okay, if someone's standing on a merry-go from the axis of rotation, this is r, and the object has a mass and it is moving with angular speed. To find the centripetal force for this object or for this guy who's standing on the merry-go, you have to use this equation. And the centripetal force for an object on a rotating body is directly proportional to r. When r increases, what happens to Fc? Also increases. In which case, when the object located on the rotating body, okay? But for circular motion, such as in this case, okay, for circular motion, when the object is moving in a circular path, okay, when the ball is tied at the end of the string and moving in a circular path, in that case, centripetal force is inversely proportional to the radius or the distance from the axis of rotation, okay? We have an important note here. Pay attention, please. Rotational motion has no centripetal force and acceleration, centripetal acceleration. Only the circular motion has centripetal force and centripetal acceleration. Be careful, okay? Don't make a mistake, because many students, they believe that the rotating object also has centripetal acceleration and centripetal force. This is not correct. Be careful. For example, when Earth rotating around itself, is it possible to say The Earth has centripetal force? No. The Earth has no centripetal force when rotating around itself. But when the Earth orbiting around the Sun, in that case, has a centripetal force which is provided by the gravitational force. Be careful. Okay? But the spinning object has no centripetal force, no centripetal acceleration. Only the circular motion has centripetal force and centripetal acceleration. So as you learned in section 1 in chapter 1 in earlier chapter, we said circular motion is a special case of a rotational motion. For every rotating object, any point on the rotating object undergoes what? A circular motion, and it has a centripetal force, such as a Ferris wheel in a game city. The Ferris wheel is a rotational motion, has no centripetal force, no centripetal acceleration. But the chairs and the ball or any point on the Ferris wheel, they have centripetal acceleration and centripetal force. Okay? What does centripetal force depends on? According to this equation, centripetal force depends on three factors: mass, square tangential speed, and the radius of the path, which is inversely proportional. Okay? And also you can see centripetal force for an object on a rotating body depends on what? Mass, the radius of the circular path, and the square angular speed. What is the useful of a centripetal force? The centripetal force is very important, and centripetal force is a force of an object that moving in a circular path which is directed toward the center. Without centripetal force, the object cannot maintain or keep in a circular path. Instead, it is flying off or moving in a straight path. Okay? So, it is very important to know that centripetal force is not acting in the direction of the movement. Instead, it is directed toward the center. Always, at each point, the direction of the force is toward the center of the circle. So, we have many sources, and we have many sources of the circular motion that maintain object in a circular path, such as the tension force, gravitational force, and the static frictional force between the tire of the car and the road. Okay, so we have many other sources of the centripetal force we will discuss after in detail, inshallah. Okay, so what is the useful of centripetal force? To maintain the object in a circular path. When the centripetal force vanishes, the object cannot maintain in a circular path. What happens when the centripetal force vanishes an object? The object cannot maintain on a circular path, and the rotated object follows linear straight path due to what? Due to the inertia. Because the inertia is the tendency of an object to moving in a straight path. Why the racing car doesn't move to the linear straight path when it is making the sharp left turn? Because of the friction. So what provide the centripetal force when a car makes a sharp left turn in a circular path? You have to say the frictional force between the tire of the car and the road. In the absence of the friction, the car cannot moving in a circular path. Instead, it is moving in a linear path, even if you make a sharp left turn by steering wheel. Okay? So we have some notes about the centripetal force. Without centripetal force, the circular motion does not occur. And the centripetal force, it causes the centripetal acceleration that acts on an object in the direction of the center of the circular path. Centripetal acceleration occurs for an object when it is moving in a circular path because velocity is a vector quantity. Its direction continuously changing, that is why centripetal acceleration is produced. The direction of the centripetal force, Fc, is perpendicular. Perpendicular to what? To the direction of the tangential speed. Fc perpendicular to the Vt, and angle between them is 90. The direction of the centripetal force, Fc, is parallel to the direction of the centripetal acceleration. Parallel to the direction of what? Centripetal acceleration, which is angle between them is 0. The object is not at equilibrium in the presence of the centripetal force. Why? Because the direction of the velocity changes in a circular path. Okay, so we will study in detail about the equilibrium, rotational equilibrium and translational equilibrium. So let me give you some information about the equilibrium. When does the object has equilibrium or becomes the equilibrium? When the object at rest or when it is moving at constant speed. Okay, in that case, net force is 0 for the straight path, not for the circular path. But for the circular path, is it possible to say when the object is moving in a circular path with constant speed and this object is equilibrium? No, never. You cannot say this object has equilibrium because this object experiences a force, a centripetal force. For the circular motion, in uniform and non-uniform circular motion, the object cannot be at equilibrium. So we cannot say this object is equilibrium. For example, the Earth is orbiting around the Sun with constant speed and constant angular speed. So is it possible to say the orbiting Earth around the Sun is equilibrium? The Earth is at equilibrium? No, never. Why? Because there is a force that acting the Earth to maintain in a circular path. This force is what? The centripetal force. Okay? In a circular motion, net force is not equal to 0, even in the case at constant speed. So instead, net force is equal to what? Fc, which is equal to mv squared over r. Okay? So the object is not at equilibrium in the presence of the centripetal force because the direction of the velocity changes in a circular path. Okay? So F net is equal to Fc is not equal to 0. No work is done by the centripetal force because it is direction perpendicular to the displacement. As you know, work is equal to what? Fd cosine theta. Okay? So in that case, because the angle between force and the displacement is 90, that is why no work is done. When an object is moving in a circular path, obeying Newton's second law, Fc is equal to mac. Okay? When the object is moving in a circular path, obeys what? Newton's second law. But when the centripetal force vanishes, okay, or when the centripetal force is, for example, is vanishes or neglected, the object obeys what? In a circular motion, Fc is inversely proportional to the radius of the path, of the circular path, because Fc is equal to mv squared over r. This relation is inversely related. Okay? In the case of speeding up, tangential speed and tangential acceleration becomes same direction. And the angle between them is what? 0. When does angle between tangential speed and tangential acceleration is 0? In the case of speeding up. But in the case of slowing down, tangential speed vt and tangential acceleration at, okay, becomes opposite direction. And the angle between them is 180. So why the ball doesn't fly off horizontally when it is tied to a string or without brakes? The answer is because this force that causes to maintain the ball in a circular path, and this force is called what? The centripetal force. This centripetal force provided by what? By tension force. So in that case, the centripetal force provided by what? By the tension force or the force of the rod. What is this? This is Ft. Provided what? Provided Fc. In a horizontal path, Fc is equal to what? Is equal to Ft. So what is provided centripetal force? The tension force. So why when a car makes the sharp left turn, the passenger slides to the right and hits the door? Because the friction between the chair and the passenger does not enough to move in a circular path, and the door, in that case, the door produces the centripetal force. Why? Because the door doesn't let you flying off or ejecting from the car. So that is why the door providing the centripetal force when you make a sharp left turn. Okay. Question 23. Why does mud fly off rapidly turning a wheel? As you can see in this picture, when the wheel is rotating, what happened to the mud? The mud fly off rapidly. Okay, why? What is the reason? Why the mud doesn't continue to maintain in a circular path when the wheel is rotating? Because the mud is internal adhesion. What is internal adhesion? Internal adhesion is the attraction force between the molecules of the same substance. Okay, so the mud's internal adhesion is not able to provide enough force to maintain the circular motion. Actually, this is the answer of the book, but it should be the internal cohesion, not adhesion, because internal cohesion is the attraction force between different molecules. The mud and the tire here is two different objects or two different molecules. Okay. Now we're going to explain the sources of the centripetal force. What are the sources of centripetal force in the following conditions? We have many sources of the centripetal force or that provided the centripetal force. The first one, look, the moon's orbit around the earth, or orbiting earth around the sun, or artificial satellites when it is orbiting around the sun in a circular path. In these examples that I mentioned, the centripetal force provided by gravitational force. Okay, as you can see in this picture, moon orbiting around the sun in a circular path. Okay, so the direction of the centripetal force is always directed toward the center of the earth. What force provided the centripetal force? Gravitational force. There is no string and there is no friction between the planets. The gravitational force provided the centripetal force in that case. Okay, so Fc is equal to Fg. Second example, car or motor turning in a horizontal turn. When a car or motor turning in a circular path, what provides the centripetal force? The frictional force or the static frictional force between the tire and the road. So in that case, Fc is equal to Fs. Okay, so for example, when a car is moving in a circular path, okay, for example, at this point, the direction of the centripetal force is toward the center. Provided by what? Provided by Fs. So that is why Fc is equal to what? Fs. At the same time, the gravitational force also acting on the car, this is Fg, and this is upward force, is a normal force. Okay, so that is why Fg is equal to Fn according to vector quantities. Okay, so as you learned in grade 11, the coefficient of static friction is equal to what? Fs over Fn. Okay? So this proof is very important. Mu s is the coefficient of static friction, is the ratio of the static frictional force to the normal force. And it is unitless. Why? Because it is the ratio between two forces. In that case, mu s is equal to Fs over Fn. Okay? So Fs is equal to what? Fs is equal to Fc. Is it possible to write Fc instead of S? Yes, of course. Why not? Why? Because Fs provided the centripetal force. So what about the Fn? Fn is equal to what? Is equal to Fg. Okay? So instead of Fn, you have to write down what? Sorry, this is wrong. It should be Fg. Okay? Fc over Fn is equal to Fs over Fn is equal to Fc over Fg. So mu s is equal to what? Fc is equal to what? Is equal to mac. What about Fg? Is equal to what? mg. M with m cancel. What does remain? Mu s coefficient of static friction. What is this? This is coefficient of static friction, mu s. The symbol of coefficient of static friction is mu s, which is equal to what? AC over G. But AC is equal to what? VT square over R over G. Okay? By rearrange the equation, mu s is equal to VT square over RG, and mu s is equal to R omega square over G. This is for circular motion when object is moving in a circular path. This is for an object when it is moving in a circular path on a rotating body. Okay? So this proof is very important. I'm gonna repeat. First, you have to know the equation of mu s. Mu s, what is mu s? The coefficient of static friction. Okay? What is mu s? Coefficient of static friction, which is equal to mu s is equal to what? Is equal to Fs over Fn. Okay, what is this? This is mu s. Coefficient of static friction is the ratio of the static friction force to the normal force. This is normal force. When a car is moving in a horizontal path, okay, so at this point, okay, the direction of the centripetal force is directed toward the center. Okay, provided by what? By Fs. So that is why Fc is equal to what? Fs. And the gravitational force is always downward. Gravitational force, and also we have a normal force to keep the car on the road. Okay? So in that case, if Fg is equal to what? Is equal to Fn. By substituting to this equation, okay, and let me write down this equation here, okay. As you know, mu s is equal to what? Fs over Fn. Okay. Instead of Fs, is it possible to write down Fc? Yes, why not? And instead of Fn, is it possible to write down Fg? Yes, of course. Okay. Fc is equal to what? Is equal to MAC. What about Fg? Is equal to Mg. These two masses cancel to each other. What does remain? Mu s AC over G. Okay? So as you know, AC is equal to what? AC is equal to AC is equal to what? VT squared over R over G. Okay? If you rearrange the equation, it becomes VT squared R G. Okay? Another equation of mu is. Now, how many equations do we have? Number one. Equation number two. Equation number three. Instead of VT squared, write what? Write down omega squared R squared over R times G. R with R cancel. What does remain? Omega squared R over G. How many equations do we have to find mu s? We have three equations to find mu s. The first equation, AC over G. The second equation, VT squared over RG. And the third equation is omega squared R over G. By using these three equations, we can finding what? The coefficient of static friction. Okay? Okay, guys. Another source of the centripetal force for someone in a rotated cylinder in a game city. Look, as you can see in this figure, okay, this guy is sticked or entangled with the wall of the cylinder because of the rotating or the spinning of the cylinder. Okay, so in that case, so this situation is completely different with the previous situation when the static frictional force provided the centripetal force. Why? Because in that case, for example, The normal force of the person's back to the cylinder provided the centripetal force. What does provide the centripetal force? The normal force of a person's back to the cylinder. Why? Because when the cylinder starts rotating, because of the inertia, the guys or the objects tend, because of the inertia, they tendency to move in a straight path. So in that case, the wall provides what? This centripetal force, which is the normal force. Okay? So in that case, Fc provided the centripetal force. Look at, for example, this is the cylinder. Okay? Spinning around this axis. Okay? So when the cylinder starts rotating, because of the inertia, the object, this is action force, okay? This is action force, and this force becomes what? Normal force. Action force and normal force. In that case, this normal force provided what? The centripetal force. So it means that for the cylinder, when it is rotating about the fixed axis, which of the following forces provides the centripetal force? Normal force or applied force? Normal force. Okay? And you can write down like that. Fc is equal to Fa. Okay? So, what about the gravitational force? As you know, the gravitational force is always downward. Fg is always downward. And there is a friction between the back of this guy and the wall of the cylinder, which is static frictional force. Why? Because when the cylinder stops rotating, what happened to this guy? It's moving downward. Because of what? Gravitational force. So, when it is moving downward, do we have friction? Yes, of course. What is the type of this friction? The static friction force. Okay? So that is why these two forces are equal. Okay? Fs, which is equal to Fg. Okay? This is for what? For the cylinder. For what? This is for cylinder case. Okay. Write down the equation of a coefficient of static friction, mu s, which is equal to what? Which is equal to Fs over Fn. But in that case, what is the equivalent static frictional force? Fg. Instead of Fs, is it possible to write down Fg? Yes, of course, why not? What about the normal force that provided the centripetal force? Normal force equal to what? Fc. Okay? Fg is equal to what? Mg over MAC. M with M cancel. Mu s is equal to what? Is equal to G over AC. Is equal to what? G over AC. And you can write down like that. G over what? AC is equal to what? Vt squared over R. Okay? Which is equal to GR over Vt squared. This is the second equation to find mu s for an object when it is rotating inside the cylinder. And also, if you rearrange this equation, GR over V, instead of Vt squared, write down omega squared, R squared, okay? R with R cancel, is equal to G over what? Omega squared R. So, how many equations do we have to find the coefficient of static friction? In which case, when a car is moving in a circular path or when the object rotating inside the cylinder? These three equations is only for the cylinder. Be careful. Okay? So, mu s, we have three equations. The first equation is equal to what? Is equal to G over AC. The second equation, GR over VT squared. The third equation, G over omega squared R. So how many equations do we have to find coefficient of static friction? By using these three equations, we can find the mu s. So this is special for the cylinder. Okay. Okay, guys. Look, we have G over AC or RG over VT squared or G over R omega squared. Another sources of the centripetal force, an object is tied to the end of the string and move in a horizontal path. In which path? Horizontal path. In a horizontal path, okay, at each point, okay, only the tension force of the rope provides the centripetal force. Why? Because FT, FC toward, FT, FC also toward. In that case, FG does not provide us the centripetal force when the object moving in a horizontal path. Okay? Which of the following provides the centripetal force for an object or for a ball when it is tied at the end of the string and twirled in a circular path? Which of the following provides the centripetal force? FT and FG, FG or only FT? Only FT. Why? Because the path is horizontal path. Okay? So in a horizontal path, only the tension force provides the centripetal force. Okay? But look at note number 5. So it's very important. Be careful. Okay. As you can see in this picture, okay, an object is tied to the end of the string and moved on a vertical circular path. Vertical circular path. What do you mean by vertical circular path? It means that like this path. Okay. The tension force of the string and gravitational force. How many forces provided the centripetal force? Two forces. Tension force and gravitational force. Okay. So in which case the tension force and gravitational force provides the centripetal force? When object is moving in a vertical path. Vertical path. Look. At the top of the path, FG downward toward the center. FT always downward. FC is equal to what? At the top, FC is equal to FG plus FT. So that is why, as we mentioned at the beginning of the lesson, the definition of the centripetal force is the resultant effective force. Why? Because sometimes more than one force provides the centripetal force, as you can see in this case. At the top, how many forces provide the centripetal force? Two forces. At the top, be careful. Okay, at top. Fg gravitational force and Ft. Okay, so what about at horizontal? This point is horizontal. At horizontal, only the tension force provides centripetal force. Why? Because gravitational force is not in the direction of the centripetal force or opposite the centripetal force. Okay? So why we got the direction of the gravitational force? Because it is in the direction of the centripetal force. Okay, but in the when the object reaches the horizontal path, okay, because this force is not in the direction of the centripetal force, or not opposite, not the same direction, it is perpendicular. For perpendicular angle, we cannot count the centripetal force. Okay, another case, at the bottom of the path, at the bottom of the path, as you can see, the direction of the gravitational force is always downward. Ft toward the center always, which has the same direction of the Fc. At the bottom of the circular path, or at the lowest point, Fc is equal to what? Fc is equal to Ft in the direction of the circular path minus Fg. Okay, so at the bottom or at the lowest point and the top point, the two forces provide the centripetal force. At maximum point, Fc is equal to what? Ft plus Fg. If they bring it in the Wizari exam, which of the following is correct for the centripetal force when the object is moving in a vertical path and when the ball reaches at the maximum point? At maximum point, Fc is equal to which of the following? Ft plus Fg. If you rearrange the equation, take Fg to the other side, Ft is equal to what? Fc minus Fg according math basic. Okay, at the lowest point, Fc is equal to what? Ft minus Fg. The direction of the centripetal force always considered as a positive sign, and the forces which has the same direction of the centripetal force also considered as a positive. But in that case, Fg is negative. Ft minus Fg. If you rearrange the equation, Ft is equal to what? Fc plus Fg. In which location Ft has maximum value? At maximum point or at the lowest point? Absolutely at the lowest point. Why? Because at the lowest point, according mathematically, is equal to what? Fc plus Fg has more value. But at the maximum point, Ft is equal to what? Fc minus Fg has the lowest value. So that is why we have a question about this. That is why the probability of the breaking the string or the rope is maximum at the lowest point than the other points. Why? Because at the lowest point, the value of the tension force has maximum value, which is equal to Fc plus Fg. Okay? But at horizontal, Fc is equal to Ft only. Okay? Because only the tension force provides the centripetal force. Another sources of the circular path or the centripetal force, when an object is tied to the end of the spring and move within a horizontal path, the elastic force of a spring provides this centripetal force, which is equal to Fc is equal to Fe, elastic force, okay, which is equal to negative Kx. Okay, a bicyclist rides on a horizontal circular track. Bicyclist rides on a horizontal circle. We have many factors that provide the centripetal force. This is not bicycle, be careful. This is bicyclist. If the question says, which of the following provides the centripetal force for the bicyclist? We have three factors. The force of the bicycle seat on the bicyclist, okay, bicyclist seat, and the friction between the bicyclist and the seat. And the last one, the force of the bicyclist legs grasping the pedal. Okay, how many forces provides the centripetal force for the bicyclist? Three factors. But if they bring in the Wizari exam, which of the following provides the centripetal force for the bicycle? Only for what? For bicycle, not bicyclist. You have to say only the static frictional force provides the centripetal force for what? For bicycle or bicyclist? For bicycle. Be careful. Okay? But if the question says which of the following provides the centripetal force for the bicyclist, it means that this is someone who's riding the bicycle. Three factors. Okay? A bobsleigh turning a corner on its track. This is such as a cylinder case. Be careful. Such as in the cylinder case, Fc is equal to the normal force provided the centripetal force. For example, if they bring in the Wizari exam, which of the following provides the centripetal force for the bobsleigh turning a corner? Normal force, tension force, gravitational force, none of them. Normal force. The normal force provides the centripetal force in two cases. In the case of the cylinder, when it is rotating about a fixed axis, or in the case of a bobsled when it is turning in a corner. A person in an airplane, as a plane turns in a circular runway, the friction between the clothes and the chair and with the seat belts. And also the movement of electron around the nucleus. You know that? The electrons orbiting around the nucleus in a circular path. So in that case, The centripetal force provided by what? By the electric force, which is equal to Kc Q1 Q2 over R squared. So in that case, mVT squared over R is equal to Kc Q1 Q2 over R squared. Okay? Question 25, look at this question from chapter review. Very good question. Be careful. A girl at a state fair swings a ball in a vertical circle. In which path? Vertical circle. When the object is moving in a vertical circle, at the top of the path and at the lowest point of the path, there is two forces acting or providing the centripetal force, which is the tension force and the gravitational force. Okay? At the end of a string, is the force applied by the string greater than the weight of the ball at the bottom of the ball's path? The answer is yes. Okay? The answer says, is the force applied by the string? The force applied by what? By the string. Okay? This is Ft. Greater than the weight, Ft bigger than Fg at the lowest point, The answer is yes. Why? Because at the lowest point, the direction of the Fg is downward. Direction of Ft and Fc is upward. At the lowest point, Fc is equal to what? Is equal to Ft minus what? Fg. If you rearrange this equation, take Fg to other side. Ft is equal to what? Is equal to Fc plus Fg. This negative becomes what? Becomes positive. So, Ft is bigger than weight? Yes, of course. So that is why the probability of the breaking the string is more at the lowest point than the other points. Very good question, be careful. Why yes? The answer is yes. Because the string must be applied a tension force that equal to the ball's weight and the centripetal force, which is equal to Fc plus Fg at the bottom of the maintained circular motion. Okay. If an object, look, this note is very important, pay attention please. If an object tied to a string and moves in a vertically in a circular path, at top point, Fc is equal to what? Ft plus Fg. If you rearrange equation, Ft equal to what? Fc minus Fg. Okay? So, at the lowest point, Fc is equal to what? Ft minus Fg. Ft is equal to what? Fc plus Fg. But at horizontal, Fc only is equal to Ft. Okay? If an object tied to the string and moves in a horizontal circular path, at each point Fc is equal to Ft. Okay? Why we need centripetal force to occur the circular motion? Because the centripetal force, okay, or the center seeking force, it means that center seeking force, they are seeking for the center, changes the direction of the tangential speed all the time and produces a circular path. Is the direction of the centripetal force is directed outward? No. Its direction is always toward the center of the node. The direction of Fc is always directed toward the center of the circular path. If an object is tied to the top of the string, at which point the probability that breaking the string is maximum? Absolutely at the lowest point. Why? Because at lowest point Fc is equal to what? Ft minus Fg. Take gravitational force to the other side, its sign changes from negative to positive. Ft is equal to what? Fc plus Fg. So at the lowest point, Ft bigger than Fg. So imagine that question 17 from chapter review. Imagine that you attach a heavy object to one end of a spring and then wheel holding the spring's other end, okay, while holding the spring's other end, and wheel the spring and object in horizontal circle. Does the spring stretch? Of course, yes. The spring stretches. For example, if you fix it or if you tie a ball with a mass, a heavy object at the end of the spring and reel in a circular path, the spring stretches until the limit of this elasticity is enough. Okay, or finishes. So the answer is yes, stretch. Why? Because the body moves in a spiral, because the object has elasticity, the spring has elasticity. Discuss your answer in terms of the force that maintains the circular motion. Because the body moves in a spiral path. Look, in a spiral path. Why? Because of the elasticity, the spring has elasticity, okay? And the inertia tends to moving away from the circular path, but the spring doesn't let, okay? So that is why the path becomes a spiral path. An elastic force in the spring, which is provided the centripetal force, which is equal to kx. Okay? Look at the sample problem 1H. A pilot is flying a small plane at 30 meters per second. What is this? This is Vt. How did you know? By the units. Meter per second is the unit for the tangential speed, which is equal to 30 meters per second. In a circular path. In which path? Circular path. With a radius 100 meters. Radius, sorry. 100 meters. Okay? If a force of 635 Newton. What is this? This is force. But which force? Gravitational force, tension force, centripetal force, elastic force. It should be mentioned. A force of 635 Newton needed to maintain the pilot's circular motion. What do you mean by needed to maintain the pilot's circular motion? It means that this is the centripetal force. Which of the following forces needed to maintain the circular path? The centripetal force, which is provided sometimes by tension force, gravitational force, static force, elastic force, electric force. Okay? So what is this force? Is Fc. Fc is given 635 Newton. For any question, if you see the needed force to maintain the circular path, it means that this force is a centripetal force. What is the pilot's mass? What is the pilot's mass? Is unknown. Which equation can be used? Which equation? Because the velocity is given, the tangential speed is given, so that is why we have to use this equation, okay? Which is equal to mvt squared over r. Cross product, 1 times mvt squared, mvt squared, fc times r, fc r. It is very important for the students to know they rearrange the equation, okay? To find mass, what is unknown here? What is unknown? Mass. Take mass to out, okay? Take out, and the variable with the unknown is always, you have to take it to the denominator, and what is remain in denominator? Fc times r. Now you can replace Fc 635 times 100 divided by 30 squared. Which is equal to what? Is equal to 70.6 kilogram. This is sample problem 1H. Sorry, sample 1H. Okay, the mass is 70. Practice 1H. This question has the same procedure of the sample problem. Okay, so the radius is 2.1, and this is Vt, and if the magnitude of the force that maintained her circular motion, which force maintained the circular motion? Fc. Okay? If the circumference of the circle is given, you must convert to the radius. According to math basic, okay, according math basic, the circumference of the circle is equal to what? The circumference of the circle is equal to 2 pi r. So r is equal to what? C over 2 pi. Look at this question. Question 2, chapter practice 1H. 905 kilogram. This is mass. Test car travels around 3.25 kilometer circular track What do you mean by this 3.25? This is C. The circumference or the circular track is given. Because of this circumference of the circular track, you can find the radius. If the magnitude of the force that maintains the car's circular motion, 2140, this is Fc. What is the car's tangential speed? Look. In this question, the circular track is given in kilometer, okay? 3.25 kilometer. You have to convert 2 meter is equal to 3,250 meter. R is equal to what? Is equal to, sorry, because C is equal to 3,250 meter, okay? C is equal to what? 2 pi R. R is equal to what? C over 2 pi. 3,250 divided by 6.28. The radius is equal to what? Radius is equal to 517.5 meters. Okay? So replace into the equation of how can you find the tangential speed? Because Fc is equal to mvt squared over r, cross multiply, mvt squared is equal to fcr. To find vt squared, both sides is divided by mass. Mass with mass cancel. Okay, what does remain? Vt squared Fc times R over M. Okay, remove this square, multiply both sides by what? By radical. So finally, Vt is equal to what? Fc times R over M. Okay, which is Fc was given 2,140 times radius of the circular path was not given. We didn't have at first, but we found it because of the radius is equal to circumference divided by 2 pi, which is equal to 517.5 divided by what? Divided by mass, 905. So Vt is equal to 35 meter per second. Vt is equal to what? 45 meter per second. So that's all for today. Hope you get benefited from my lesson and thank you for listening. Inshallah, in the next lesson we will continue to solving all questions related with the centripetal force.